Hello, we are happy to share with you our work on indoor scene augmentation via limited scene priors. Contextually completing scenes via learning-based scene synthesis techniques has recently gained momentum in computer vision and graphics communities with applications in augmented and virtual reality. However, a major challenge in the field is to train models with limited datasets reflecting real-world functional arrangements of indoor scenes. Synthetic priors used in many state-of-the-art scene synthesis methods may not always capture the natural relationships of objects in real-world settings. Therefore, we define our challenge as performing scene augmentation with limited scene priors. In our proposed method, we introduce a novel scene graph representation where objects are defined as nodes and the edges correspond to topological relationships between the objects. With these graphs, we train a knowledge model to recognize graphs associated with the plausible scenes. In our first attempt, called SceneGen, we use kernel density estimation with input vectors that summarize graph structures. In our follow-up work, we improve upon the model architecture via GSACnet, an algorithm that combines graph attention, Siamese, and autoencoder networks to assess the plausibility of the graphs. An integral part of our implementation is to take advantage of parametric data augmentation methods. This allows us to augment the small dataset in a parametric fashion. This slide offers visual representation of our results. Additional illustrations can be seen in our paper. After conducting ablation and comparative studies with state-of-the-art algorithms, we observed that for most object categories, our model predicts placements with smaller distance errors from the ground truth. Finally, to demonstrate our system in action, we present an augmented reality application in which objects can be contextually augmented in real time. Thank you very much.